Practice exercise 16.10 stretch might be a little bit deja vu for you because I previously did this problem already in the playlist link below the like button. Don't spoil it for yourself though. If you haven't looked at it, go look at the other one because we're going to be solving this but using recursion. This one was a tough one to do. 16.10 stretch with recursion. This is it without recursion right here. This is the normal way of solving it. It passes the tests, of course. So go check that out if you haven't already. Now let's code it in recursion. So this is going to be the same. Public void stretch, we're taking an integer n, and then we're going to be inside of this method. Now, how do we do this? First, let's take care of this case right here. So if the value n is less than or equal to 0, our list should be empty after the call. Well, remember, front with this private list node is going to store the head of our list. So we'll just set front equal to null, and that will take care of that. That's the easy part done. Now let's get into the recursion. So we're going to throw this into another method. Since we're using object-oriented programming, I'm going to break this up in as much steps as I can. It actually makes it easier to understand. After we do this, if we don't need to set our front to null, let's push this into a recursive method. So I'm going to just call it recursion 1, and if you were actually coding this, you'd probably want to call it like recursion or stretch recursion 1. That's what I would do. So you know what? Let's actually do that. Let's be legit when we're solving this. So stretch recursion 1. I'm going to make this a private method, so only this method has access to it, where it's basically going to only be a helper method. Inside of here, we are going to pass in a few things. First, we're going to pass in the front of our list, and this is important because we recursively need to pass in a list node as we do this. So front and n, basically it. And then we can close off this stretch method here. Now let's get into the fun stuff, the recursive stuff. So private, it's going to be a void or not? Well, this is a little bit tricky because at first I thought it was a void, and then I realized it's something else. If you don't know what it is, let's just put void for here, and we'll get into it in a second. I'll have a whole diagram explaining all this because it's super cool how this works. Private void, and we're just going to call it obviously the same thing, and we need to pass in front, which is a list node front, and then our int n. Now, if you remember previously how we did this, it was done with a while loop. It went through this list until our current value was null, then it would stop. And that is a good base case here. So let's run this as long as our current is not equal to null. So if current does not equal to null, we're going to want to have some code inside of here. Now, what do we want this code to do? That's what we really have to ask ourselves. That's what you have to ask yourself when you're coding any program. What we want this code to do is follow this diagram that I'm about to create for it. We know that we have a front value, right? Front is currently equal to 18. Let's just put D in here for data, and we have a pointer to the next node, which is currently going to be 7. But that will be, we'll just put it over here, 7. Currently, this points to 7, but we want to reassign this. And so to do that, we're going to push this into another method, another recursive method, where we can handle this. So let's make that second recursive method. It's going to be, and remember, this isn't done yet. So this right here, let's just close it off for now, but we're gonna come back to it in a second. We're gonna call this private void, and we'll do stretch recursion 2. I spelled that wrong, so I just copied it down here. And for this one, we need to pass in more than just a list node front and int n. We also have to pass in something else, because remember, this has to add it a certain amount of times, n many times. We're going to need something that is a counter against this. And so I'm going to pass in int counter. And so that means inside of here, wherever we have the call to stretch recursion 2, we're going to need a counter value to be passed in as well that we need to create. But I'm just going to put this in here for now. So our base case is just going to be pretty simple as well. If our counter is less than n, because remember, that's kind of what we had down here for this for loop, except a was the counter. If counter is less than n, we're going to have the same process where basically we're going to want to take this data value, we are going to want to put it into this next part and then make a link to the next node, which would be 7. You don't want to lose that link. Super important. Currently, right now, our current is still pointing to our front because we never reassigned it. So once we do this process, we are going to also have to reassign our current value. So just keep all of this in mind and let's code it out. First, we are going to set current.next to the data and the pointer to the next node. That's going to be this part right here. So to do this part, keep a mental picture of it, we're going to set current.next, because that's the next value right here, equal to a new, we'll have ListNode, and then inside of here, we are going to have our current.data. Currently, this is the front, this is 18, and then we need to store or make a pointer to the next part. So that's going to be current.next. That's going to be this pointer part right here. So current.data is this part, current.next is this part. And now, afterwards, we can reassign this right here, which is our current pointer. So we can say current is now equal to current.next. And that's pretty much going to be it for that part. Now, this has to recursively call recursion 2 again, because it needs to go through and continuously add this n many times. So that means we're going to have to increment our counter every time this runs. So after we look at our counter, we can just do this plus plus. Again, we have to pass this to our stretch recursion 2. So inside of here, we need to pass in our new front value, which is basically what this arrow is going to be pointing to. It's no longer front, it's going to be current. In fact, we should change this name to current just for our sanity, so we don't always keep thinking it's the front. We're going to pass in current. We are going to pass in our n still, that's unchanging, and we're going to pass in our updated counter variable. And that's pretty much going to be it for that recursive part. We can close this, and it's going to run through it again because remember, we were passed in 3 for this example. So it's going to go through it again. Remember, data is now inside of here. It's going to, with the current.next part, it's going to look at this pointer right here, and it's going to make a new node. It's going to say our current.data, which is this one right here, current.data, because we're looking at this one still. And then we're going to make a new pointer, and then after that, line 15, we're going to say current is equal to current.next. So that's going to move the pointer here. And then we're going to call the recursion again. However, since counter is now the same size as n, we aren't going to go through this. So we're just going to unwind. There's nothing after this sketch recursion 2, so we're not going to use any code after that. And all we're going to need to do is return to sketch recursion 1. So inside of this if current part, that means we're going to have to first fall into here. We're going to set current equal to, and this is basically going to store this current value right here. Current is equal to sketch recursion 2, and we're going to pass in our current value. We're going to pass in n, and a, remember, starts at 1 down here, so that means our counter is going to always start at 1 as well. And that's just for how many times this needs to print out. It doesn't start at 0, otherwise it prints 1 too many times. This current is going to hold the result from all of this, meaning that instead of being a void, this needs to return a list node. So we are going to return, after all this is done, when we're done with this recursion, we're going to fall into this return, and we're going to just return our current, and we can end this. Pretty much done with this private list node. So after it does this portion right here, we are going to want to, because this right here actually links to the 7. What we're going to want to do is we're going to move our current pointer to this 7. And that way, afterwards, we can call sketch recursion 1 again. And that's basically going to loop through this, go back to line 9 where we have sketch recursion 2, fall into it, and repeat this whole process right here again over here for the next value, and so on and so forth. So we're going to set current equal to, and then we're going to do a current dot next, so we're moving it over, and then we're basically just going to call our sketch recursion again. And then we're going to store this inside of our current value. We're going to store into current our sketch recursion 1 recursion. So inside of here, we're just going to pass in our current value, and then we're going to pass in n as well. Let's change this from front to current, just so we can stay consistent. Otherwise, we need to change this to front because this is what this is referencing. Because we have this current equals sketch recursion 1, this needs to change to a list node. So we're returning a list node because this returns this, since we are using recursion and recursively going through here. And so outside of this if statement, when we're done with this entire recursion part, we're going to need to return our current. Now, to clean this code up a little bit, we can actually take out this line and just put current.next into here. So we can remove what we had previously, which was current, and then we can do the same thing for this one. So take this out and then remove our current and instead have current.next. And that's pretty much it. Let's run through the logic again really quickly. Using the example previously where we started at 18 and then we had 7, we'll just use these two and then our n was 3. So looking at lines 1 through 6 for the first method, this is essentially just passing in the front of our list. So that's going to be this portion. Remember that there's always a data right here and then a pointer to the next spot. This part itself is being passed in to our next method, as well as our n. So as long as current does not equal to null, as long as we've not hit the end of this list, we're going to keep going down this if statement or recursively looping. Also note that current is the head right here, so it's pointing to this. It's currently pointing to what we have right here. So now we're basically reassigning our current. Current is equal to sketch recursion 2, where we pass in our current value, which is going to be this 18 with a pointer to the next. We pass in n, and then we pass in a 1. So now we're going to have to go down to this private list node, lines 15 through 22. Inside of here, we have another if statement where we're basically running this as long as we have a, which is our counter, which is less than our n. We have current.next. Remember, current is this right here. The .next is this portion right here. So we're inserting a new link. Current.next is equal to a new list node. We're reassigning this. So the 7 is actually going to move over 1, and in its place, we're having current.data. This is going to be our 18. I'll just put a D here, and then current.next. This all happens on line 17. And then after this, we're going into sketch recursion 2 again, passing in our current.next as our list node current. So our list node current now points to this right here, and then our n and our counter. We're going to do this again, where 7 is actually moving over, and so it'll be right here. We have a data being pushed in here and then a link to the next node. This happens again on line 17. And then on line 19, where we do current.next, we're basically just going to move our current pointer over 1. And then when we recursively go into here, we're going to see that our counter is now the same size as 3. So we're done. We're going to break out of this. The only problem here, actually, I just realized, is that this result right here is going to be a list node, and this is going to be returning. So this actually needs to be set to current. So current is equal to stretch recursion. When we're completely done with this though, we are going to return our current, and our current is going to be pointing to this right here. Now we're going to be back in our stretch recursion 1. From here, we are going to want to point to this 7 value, right? So we can get this. This we want to be our new front, so that we can repeat this whole process instead of 18 with 7. So we need to move this pointer over 1. So we're going to do a sketch recursion 1, recursively do this so we can redo this whole thing. We need to move current over 1, so current.next is going to be the list node that's passed in. Of course, we pass in our n, and since we are returning a list node, eventually we're going to have to return. And that is how the recursion would work for this problem. This is the little diagram for it that we drew out, drew a few of those. That's going to pass 7 out of 7 of our tests, and that's going to be it for this practice exercise 16.10, which is stretch doing it through recursion.